chunks. So today's topic is the loft. Hopefully you can see my screen here. I'm working off a Wacom tablet in my office. I'm getting more and more used to using this as a tool. And so the loft. So hopefully you can see this. My handwriting is not any better with the Wacom tablet. But a loft. In CATIA, that's called a multi-section. Multi-sections. I like to emphasize the plural on that. Sections solid. And the negative space counterpart would be a remove multi-section solid. So these are your loft tools. So what is a loft? So just a general definition, it's going to be two or more sections. It's the plural here, two more sections coupled together. Now, I will tell you there are scenarios where you can do one section, but as far as this class definition goes, it's two or more sections coupled together. So what does that mean? So sections. So the sections are really what profiles have been up to this point. So sections would be similar to doing a pad, except you've only got one profile there, whereas this has more than one profile. So they're referred to as sections and not as profiles, but the same basic rules apply. It could be a sketch. It could be a wireframe entity. I'm going to try to show that one to you today. It can be a wireframe as long as it's planar. It's got to be planar. We looked at a wireframe entity. We've looked at wireframe entities before, such as the helix, and obviously the helix is not planar, so that would not serve as a section. But if you did a closed spline, and as long as it's planar, it will work. It can also be a surface, but that's really advanced. So it's sections. So two or more sections coupled together. So how are they coupled together? So I'm going to talk about coupling here. Coupling is just another word for joining together. So it's just another word for joining together. So there are multiple ways to couple them together. The first one is, so how do I even want to call this? I'm going to call it manual coupling. You won't see that listed in CATIA by that name, but I have seen it in CATIA's documentation referred to as manual coupling. And this could be an explicit or implicit way to couple. And I'm going to show you what I mean by both. And those are really more my terms than CATIA's terms. So this will be the first thing I show you is manual coupling. I'll show you an explicit way, and then I'll show you an implicit way. Actually, I'll show you implicit first and then explicit second. So intentional and non-intentional is another way to look at that. Another way to couple is via guides. So those are the two primary ways I want to show you today. So manual coupling and then also coupling with guides. So there are 4 coupling modes. Oops. I'll tell you what, before I get into coupling modes, let me talk about a couple of things. I want to try to draw some pictures here. I need isometric grid paper for this, but I don't think this tool I'm using here has isometric. Let me draw an isometric. I'm going to draw a rectangle in isometric. Oh, that's really bad. Let me use the line tool here. There's a line. So that's supposed to be a rectangle. And then I'm going to draw that. So that's one section. Just imagine that you drew that in as a sketch, and it's just a rectangle. So it's closed like it should be with any part. By the way, so sketch-based features, you've got pads, you've got revolves, and you've got sweeps, and you got lofts. So those are your four basic sketch-based features. So you've got revolves, extrudes, you got sweeps, and you got lofts. Some CAD systems will combine a sweep and lofts together into one type of tool, and that's okay. You just got to get used to it. I think NX does it that way, and there's other tools I've seen that do it that way. The sweep and the loft will be kind of joined together, and you can kind of do that in CATIA as well. But it's back to this. So this is a loft. Now I remember what I was going to say. This is the only of the four extrusions, revolves, sweeps, and lofts that we've covered. In other words, pads, shafts, ribs, and now multi-section solid. This is the only one of the four that doesn't have the thin, thick option. Remember that, where you can extrude something and then it has a thin wall on the outside, whatever wall thickness you set. This is the only one of the four that doesn't have that thick option. Okay, so just keep that in mind. So back to where I was. So I'm going to draw another section here. This is going to be a rectangle as well. My best isometric sketching. It's really bad, but all right, so I've got two sections sitting out there. Just imagine, just think of a scenario here. I sketch one section on a default reference plane, then I create another reference plane out here in space, and I did the offset reference plane tool. And you can just imagine maybe they're separated by 10 inches or something like that. So they're sitting out in space. So what happens with coupling is so each section is going to have a coupling point. And so CATIA calls that a closing point. I sometimes will refer to it as an opening point or a starting point. So if I say starting point and CATIA calls it a closing point, just think of them as the same thing, okay? Because different CAD systems have different names for it, but they all have this similar principle. So I think CATIA calls it a closing point. Now I'm getting confused to myself. Is it a starting point or closing point? But let's say it's a closing point. And then it also has a closing direction. And so when you pick a section to include in your loft, CATIA is going to give you a closing point. And you've got to be very, very intentional about where you want that closing point to be. So CATIA is going to put it in based off of how you created the sketch. And I think it puts it in at the very first point in your sketch. So just FYI. But you can move it to any one of these other 4 points, other 3 points, I should say, or any other point that lies on the wireframe geometry. So you could have used the reference point tool and put that in on curve and had one out here. You can do that as well, and you'll see that in a few minutes. So it will show you a closing point, and then also an arrow that represents the closing direction. So you can move the closing point around, and you can flip the arrow direction. So this section will have a closing point and direction. And when I do this section, it needs to have the same, essentially in the same location, very close to the same location. In this case, it's very obvious where it needs to be, but not all your geometry are going to be the same. I could be going from a rectangle to a circle, or maybe a rectangle to a triangle, and then you got to be put a little more thought into where that closing point needs to be. So each section will have a closing point and a closing direction. And then the sections will be coupled together, starting here. So this will be my first couple, 1 to 1. And let me draw a line here instead of the sketch. So it will have a coupling line, This will be 2. Stop it. This will be 2 and 2. And so the coupling line will be here. And this will be 3 and 3. If you ever square dance and you are matched up as a couple, it's kind of like a similar thing, right? So 4 and 4, except CATIA, you can have couples that are more than 3, kind of like a modern day couple. So then there's 4 to 4. So these, I guess these are yellow, represent the coupling lines and the coupling points. And that's how they will be joined. They're joined based off of these coupling points. And these are more of an example of manual coupling and explicit. So this is more of the explicit type here, because I'm letting CATIA do the work for me as far as finding those points. I've just got to be very, very intentional where I put my closing point and also my closing direction, making sure they're all matching up. Now, last thing before I do a little demo here, these are your coupling modes. Stop it. Let me talk about coupling modes. Coupling modes. There's 4 of them. You have ratio. You have tangency. You have tangency then curvature. Then curvature. Curvature. Probably spelling it wrong now. Curvature. It's supposed to be curvature. So when you goof up your spelling, you just kind of scribble it out and then tell them what it means. And then the last one is vertices. Okay. So of these coupling modes, I want to let you think. This is right here. What do you think I think about this coupling mode? I'll let you figure out what the F stands for, but this is a frowny face. Tangency, oops. Tangency here is a more like a C face. Tangency then curvature, big happy face with an A next to it, and vertices, frowny face with an F next to it. So vertices, or tangency then curvature, is a big smiley face with an A next to it. Ratio is a frowny face with an F next to it. So which one of these 4 do you think I prefer?
Probably vertices.
Because I won't frown. I want to be sad all the time and receive an F grade. Yeah, that's exactly the reason why. Any other wild guesses? I've kind of got my drawing off. This is probably what threw you off here. That's the face for this one. Now, what do you think what am I looking for here? Tangency then curvature is what I'm looking for. Did I spell that right? It's called tangency then curvature. That's the expectation. Tangency then curvature. It provides by far the best coupling. Tangency is okay for part of the model, and in other parts of the model you may have issues. Ratio is poor. You will get 0 points if you do ratio. Are you tracking me here? Am I saying this enough? Ratio is equal to 0. Okay. tangency is equal to A. If you have to do tangency, the curvature. If you have to do tangency, then you'll get partial credit. But if you do vertices or ratio, you get 0. All right, so just please, I can't highlight this enough. First thing I check when I see a multi-section surface or solid, because this is true in surface only too, is I will check the ratio, coupling mode. If it's ratio, I don't give any points. And I used to pay my old graders by the number of ratios she found. Just kidding about that. So pore surface, I'm going to show you an example here as well. So just keep that in mind, okay? Pore surface. That's all I want you to know right now. And so let me go to CATIA and let me add that. And let me go to my demo here. Okay. That's similar to what I just drew. 2 rectangles. I've got an offset reference plane. I'm working in millimeters here. Doesn't really matter. I'm going to make my part to define a working location. So I'm in the part design workbench. All is good. So sketch space features toolbar. There's my multi-sections solid tool. Below it is removed multi-section solid. So let's do multi-section solid. If I call this a loft, by the way, I mean the same thing. So this is a loft. So at the top here, I've got my sections, and you can have 1 or more, but in this class, it's 2 or more as far as definition. There are scenarios where you can get by with 1, but as far as my definition of a loft, I want you to think 2 or more sections. So I want to follow me carefully here. Very, very carefully. So I'm going to come in here and I'm going to go and I'm going to select this section first. And the very first thing I'm going to look at is my closing point. And there it is. It's showing right here. At this stage of the game, select where you want the closing point to be. If this is not where you want it to be. So I'm just going to leave it there in the lower right-hand corner for now. It could really, practically speaking, be any one of these 4 points at this stage of the game. And all I've would have to do is just pick a point and it will change it to that location. Sometimes it's hard to pick the point that has the section label here. So, but I can pick it on the tree if I needed to. I'm going to move it back to here. But you can also flip its direction for the closing direction. I remember I mentioned that. Okay, moving on here. Next section will be here. Now, notice where it put my closing point. So I've got to be more intentional, and I'm going to pick where I want it to be, which is right there. So notice, same relative location, same direction. Now, disregard where they're still both going in this, the way I'm looking at it, counterclockwise, which is fine. And now, I'm going to jump over to the third tab, and I'm going to look at my coupling mode. And here, there's my 4, ratio, tangency, then curvature. Hey, I left off the V. I was wondering what was going wrong with curvature. Left off the V. So I'm going to go to tangency and curvature, and this should work, and it does. Because this is manual coupling implicit. I didn't have to do anything to get it to work. Listen to this carefully. The reason why it worked without me having to do anything is because each section had the same number of vertices, 4. Okay? Tracking me on that? Now, if I change this to ratio, in a preview, notice the extra lines that are put in. So notice I got an extra couple of lines there and up here. That makes it a extra coupling lines, extra topological areas. And notice notice what's happening here. If I get kind of this angle here, you can see what's happening to my surface here. And I could probably look at that up here as well. Creates a pore surface. See how it's pore model. See how it's kind of doing this little blending thing going on here? Pore. That's why I don't want ratio. That's why that's why I have a frowny face on ratio. Okay. Now tangency is probably going to look a little better in this scenario. Tangency works fine in this scenario. And tangency then curvature works fine in this scenario. Questions about that? Also notice here while I'm doing this, there's no thin or thick option. Okay. That's the very basics. I'm going to stop recording.